Good morning, everyone. Today we'll be going over the second review packet. This is the one that I handed out in class yesterday, and I wanted to remind you all that tomorrow is the Unit 5 test on proofs. So we're just going to go through the review packet. Hopefully you did this for homework last night, and we'll get through as many of these as we can during this period. So in number 1, you were asked to prove that triangle AED and triangle BCF are congruent to each other. So I'll go ahead and highlight those. And we were given E is congruent to C, ADE is congruent to BFC, and segment EF is congruent to segment DC. So I'll go ahead and mark those in. Now in this particular proof, after marking in the given, I notice that angle E and C is a pair of angles in the yellow and the pink triangle. Angle ADE and BCF is another pair of angles in the two triangles. But this pair of segments, EF and DC, is longer than the sides of the triangle ED and FC. So this is an example where, since the segments they're giving us are longer than the segments of the triangle, we're going to need to take something away from each of these. And in this example, what we'll need to take away from both is this segment DF. So this will be a proof that involves the subtraction process. So I'll start off by taking EF and DC and writing them out as the sum of their parts. So using the picture, EF equals ED plus DF, and DC equals DF plus FC. And again, that's a whole equals the sum of its parts. And we always follow a whole equals the sum of its parts up with substitution next. So since we know EF and DC are equal, I can then set their right sides equal in the second statement, leaving me with this. And since I'd like to take something away from both sides, I need to first in my proof have written out that what I'm taking away from the left and what I'm subtracting from the right is equal to one another. So in this example, notice how the two segments we're given overlap at DF. In order to subtract it from both sides, we're going to need to say that DF is congruent to itself. So not only do we use the reflexive property when we have shared sides or shared angles, but we also use it when we need to either add the same segment to two other segments or take away the same segment from two segments or two angles. And this would be a pair of sides now, ED and FC, in step 5 actually, where we'll have ED and FC are congruent. And that's by subtraction, since I can, in step 3, take DF from the left and DF from the right. So that's the subtraction property. And now looking at my diagram, I should have enough information to prove triangle AED is congruent to triangle BCF. And that's by angle side angle. Great, hopefully you got that one right. Let's go ahead and take a look at number 2. In number 2, again, we're asked to prove triangles are congruent. This yellow triangle ABC and this pink triangle ADC. So we'll go ahead and write down the given. And I'm going to go ahead and mark that in the diagram. So I'll start with the second piece of given information. They're telling us in this one that angle BAE and DAE are congruent. Now, unfortunately, this isn't a pair of angles in the yellow and the pink triangle. However, hopefully you notice that these angles do form what we call linear pairs with these angles that I've labeled with a 1 and a 2. So if these angles BAE and DAE are congruent, since they're angles on a line with angles 1 and 2, 1 and 2 must also be congruent too. So that's how this piece of given information helps me with angles of the triangle. Now, in order to do that, it takes 2 steps. I need to first say that angle BAE and angle 1 are supplementary. And I also need to say that angle DAE and angle 2 are supplementary. And this is from a reason we've used a lot earlier in the year, which is angles on a line add to 180. Or to make my reason match my statement, I'm going to say angles on a line are supplementary instead. Good. Now in step 3, I'm able to say that angle 1 and angle 2 are congruent. And that's because supplements of congruent angles are congruent. And we'll go ahead and mark that in our picture. And that's a pair of angles toward one of our triangle congruence theorems. Now we'll go back to the other piece of given information. EC bisects angle BCD. So remember, whenever we're given a bisector, it's whatever follows the word bisects that's divided into 2 equal parts. So in this example, BCD is this angle on the far right. So that means these 2 angles would be congruent. And I can number them with a 3 and a 4. So 3 and 4 would be congruent. And that's because of our definition of an angle bisector. An angle bisector divides an angle into 2 congruent angles. Great, and that's another pair of angles in the yellow and the pink triangles. Now I'm out of given information. Turning to my picture, I notice that these 2 triangles share side AC. So I'll use the reflexive property for that included side. And then I have all the information I need to prove that triangle ABC and ADC are congruent. By angle side angle. Good. Let's go on to number 3. Without going entirely through angle 3, this one's going to work out very similar to the last one. If I want to show triangle ABC and triangle ADC are congruent, I'm given AC bisects both angle BCD and angle BAD. So that means both BAC and DAC will be congruent to each other, and BCD will be divided into 2 congruent angles also. And that reason's because an angle bisector divides an angle into 2 congruent angles. Since the diagram looks just like number 2, I can use the reflexive property with segment AC. And again, this triangle proof ends with angle side angle. So we won't list out I won't go over the entire proof listing out the statements and reasons because it's so similar to number 2. Next, we'll look at number 4. Here we're asked to prove triangle ACR in yellow is congruent to triangle ABR in pink. Again, we'll start with the given. We're given perpendicular lines, AR and CB, and that R is the midpoint of CB. So marking in the perpendicular lines, we're able to say that these 2 angles, angle ARC and angle ARB, are right angles, since perpendicular lines intersect forming right angles. And then we can go ahead and say that those angles are congruent. Now, as I mentioned in class, sometimes it's helpful to look ahead a little bit in the proof to determine if we're going to need to say the triangles are right triangles or that the angles are congruent. And the one case where we do want to say that they're right triangles instead of congruent right angles is if it's going to end up as an HL proof. But looking ahead at the given, I've noticed that this one won't end with HL. So we've used the perpendicular lines to get a pair of congruent angles. Next, we're given a midpoint. That tells us CR and RB are congruent to each other based on the definition of a midpoint. That is, a midpoint divides a segment into two congruent segments. Now I'm out of given information. I have a pair of angles congruent and a pair of sides congruent. So looking at my picture, I notice the two triangles share side AR. So I'll say that AR is congruent to itself by the reflexive property. And that's another pair of sides in the two triangles. So now, based on the diagram, the triangles would be congruent. And that would be by side angle side. So far, the proofs that we've went over should have been pretty straightforward. They are going to start getting a little more difficult as we move on further in this review packet. Let's take a look at number 5. Here we're asked to prove that segment AE is congruent to segment BF and that angle E and angle F are congruent. Now, both of these pairs of corresponding sides and the pair of corresponding angles are part of these two overlapping triangles. So in this one, we're going to try to prove triangle AEC is congruent to triangle BFD first. And then we should be able to end with CPCTC. So let's go ahead, write down the given and see how much this helps us. They're telling us angle BAE is congruent to angle CBF. Angle BCE is congruent to angle CDF. And segments AB and CD are congruent. And we'll go ahead and mark this in our diagram. So here's angle BAE and CBF. That is a pair of angles in the yellow and the pink triangles. BCE and CDF, that's actually another pair of angles in the two triangles. And segment AB is congruent to segment CD. Now, in this third piece of given information, they're telling us these segments are congruent. But AB and CD aren't sides of the yellow and the pink triangle. They're actually too short to be sides of the yellow and the pink triangle. Which means I need to add something to both of them in order to get our remaining pair of sides to prove the triangles are congruent. And the segment we would need to add to AB to get the side of the triangle AC would be BC. And the segment that we need to add to CD to get BD would be BC. So this is going to be an example that uses the addition process, which remember is 3 steps. And in order to use addition, I first need to show that segment BC is congruent to itself, because this is what we're going to add to the segments that we're given are congruent. So in this one, we'll start off with the reflexive property with that segment we need to add to both AB and CD. Then we'll use addition, where we add AB and BC, which are the left sides of these congruent statements, and CD and BC, which are the right sides of the congruent statements. And this is the addition property. And our goal is we'd like to replace AB plus BC with the side of the triangle, which is AC. So next I'm going to say AC is equal to AB plus BC. And we'd like to replace CD plus BC with the side of the triangle in the pink triangle, which is BD. So I'll say BD equals CD plus BC. This is a whole equals the sum of its parts. And I can tell this is true from the diagram. And that sets ourselves up to use substitution, where I can replace AB plus BC with AC, since we know those are equal. And I can replace CD plus BC with BD, because in statement 4 I stated that those are congruent. And this would be substitution. And that's our pair of sides we need for the yellow and the pink triangles. So now we have enough information, if we take a look at our diagrams, to use angle, side, angle to prove the two triangles are congruent. And that would be triangle AEC. And make sure you're matching up the corresponding angles with BFD. And then we really can do both proof statements in the same step, because AE and BF is a pair of corresponding sides of those two triangles, and angle E and F is a pair of corresponding angles. So I'm going to include those both in my step number 7, and the reason is CPCTC. Corresponding parts of congruent triangles are congruent. In number 6, we're asked to prove that triangle SRQ is congruent to triangle STP. Again, I'll highlight those in yellow and pink. And then we're asked to prove angles R and T are congruent, which in this case, those are just angles in those two triangles that correspond with one another. So if I can prove the triangles are congruent, I can use CPCTC to say that this is true. So again, we'll write down the given. And I'll label that in my picture. So here's SPR, that's that whole side, SQT, this whole side, and PR and QT. So when I look at the given, SPR and SQT is a pair of sides in the yellow and the pink overlapping triangles, but PR and QT are sides of these smaller triangles, not the larger overlapping triangles. So since we're given the whole side SR and ST are congruent, and we're given that part of those sides are congruent, PR and QT, if we were to take away PR from SR, we'd be left with SP, which is the side of this pink triangle. And if I took ST and took away QT, I'd be left with SQ, which is the shorter side of the yellow triangle. So this is an example where we'll need to use subtraction in order to get another pair of sides in the two triangles to be congruent. So in order to use subtraction, I start off with a whole equals the sum of its parts. Looking back into statement 1, I take the longer segments that I'd like to subtract something away from, and I'm going to write those as the sum of their parts. So SR in the picture is made up of SP and PR, and SQT, or I can just call it ST with 2 letters, is equal to SQ plus QT. And again, that's a whole equals the sum of its parts. And we always follow this up with substitution. So if we know SR and ST are congruent, that's the left side of these two statements. I can also say the right sides are equal. So SP plus PR is equal to SQ plus QT. Again, that's by substitution. And then the subtraction comes between steps 3 and 4. Since I know PR is equal to QT, I can subtract those from the left and the right sides of this previous equation, and that leaves us with SP is congruent to SQ. And I've already labeled this in my diagram with 2 markings. It's by the subtraction property. And that's a second pair of sides in the 2 triangles we want to show are congruent. And we're out of given information, so looking back at the diagram, sometimes it helps to draw the triangles out separately. One of the triangles that I highlighted in yellow is SQR, and the other triangle that I've labeled in pink is SPT. And we knew these shorter sides were congruent. I marked that in with 2 markings, and we were given the longer sides were congruent. And looking at the triangles separated, I noticed that angle S is really a part of both of those. It's one of the angles in both of those triangles. So since they overlap there, that'll give us an angle. Angle S is congruent to angle S by the reflexive property. So now we're able to prove that triangle SRQ, and I'm going to use the same order they asked us to prove this up above, and triangle STP are congruent, and that's by side angle side. And then we can say that angle R is congruent to angle T by CPCTC. In the seventh proof, we're asked to prove that E is the midpoint of FEG. So in order to do that, in order for E to be the midpoint of FG, we would need to show that this segment FE and this segment EG are congruent to each other. Now, there's a few ways to do this, but in order to try to prove a pair of triangles are congruent and then use CPCTC, we could either show triangle DEF and BEG are congruent, or we could prove triangle AEG and CEF are congruent, since FE and EG are a pair of corresponding sides in both of those triangles. So in this one, in order to work backwards, I'm going to first actually list out the given information to see if we have more information for one of those pairs of triangles than the other. So we're told AC and DB bisect each other. And the second line of given information really just describes the picture, so that doesn't really give us any helpful information other than what the picture looks like. So I'm going to omit writing that all out. But using the first piece of given information, if AC and DB bisect each other, then that allows me to say two things. AE is congruent to EC, and DE is congruent to EB, both, because of this key part that they bisect each other. So I'll list that in my second step, that AE and CE are congruent, and then that DE and BE are congruent as well. And the reason is a segment bisector divides a segment into two congruent segments at its midpoint. Some geometry teachers require you to take 2 steps to write out that you have congruent segments when you're given a segment bisector. I allow you to do it in 1 as long as you remember this at its midpoint part in the reason. Now if I take a look at my diagram, I also notice that I have vertical angles. And I have vertical angles for these larger angles at point E, vertex E, and for either of these smaller pairs of angles. So based on the given information, this gives me 2 pairs of sides, but not of either of these smaller pairs of triangles, but instead of the larger triangles, triangle DEC and BEA. So it seems as though I have enough information with the vertical angles to prove those are congruent first, even though they're not the final pair of triangles that I want to show are congruent. But these will be helpful. So let's prove that triangle AEB and CED are congruent. And oops, I can't actually say the triangles are congruent until I prove that those angles are congruent first. And we know these angles are congruent because vertical angles are congruent. And I'm going to leave a little space here because I'll probably have other vertical angles that I need to list out in just a minute. And then we can say the triangles AEB and CED are congruent by side angle side. Now at this point, based on my diagram, it looks as though it doesn't really matter which pair of these smaller triangles I ultimately show are congruent. So I'm just going to highlight DFE and BGE. And from the given, I have a pair of sides, BE and DE, of those triangles. And I can use vertical angles, similar to what I did with the larger triangles, to prove that DEF and BEG are congruent. So I'll go ahead and add that to my step number 3 since it's for the same reason. DEF is congruent to BEG. And that's a pair of angles in the yellow and the pink triangle. And from the given, we run out of information. But since we just proved these larger triangles, AEB and CED, are congruent, we can use CPCTC in order to fill in the remaining pair of angles or sides that we need for the yellow and the pink triangle. So looking at these larger triangles, I can go through each pair of angles and figure out which pair of angles or sides in the larger triangles is also a pair of angles or sides in the yellow and the pink triangles. And I notice that angle D and angle B is what's going to help me with the smaller triangles. So we'll say those are congruent by CPCTC. And that's another pair of angles in the yellow and the pink triangles, allowing me to show that they're congruent by angle side angle. So that would be triangles DEF and triangle BEG. And again, that's angle side angle. Then, when we thought backwards originally, in order to show we have a midpoint, we need 2 congruent segments. So in this one, we would want FE to be congruent to GE. And those are corresponding sides in the yellow and the pink triangles. So I'm going to use CPCTC. And then we should be able to say that E is the midpoint of FG. For some reason, my pen gets messier and messier. It's not as responsive as I finish a proof. So sorry, this is a little messy. A midpoint divides a segment into 2 congruent segments. Great. And I believe we have one more, which is proof number 8 on the next page. Now this one's a little bit different because we're given a pair of congruent triangles and we're asked to prove that AD and BC are congruent. And as you notice when I highlight these sides, AD and BC are not a pair of corresponding sides in these yellow triangles that we already know are congruent. But we can use CPCTC right off the bat with these smaller yellow triangles. So let me go ahead and write down the given. We know we have those congruent yellow triangles, and DE and CF are also congruent. And I'll label that here as well. So in order to prove these red segments are congruent, I want to prove these larger triangles are congruent first. That would be, if I think backwards, triangle ADM and triangle BCM. Now, to do that, the given information doesn't give me any pairs of sides or any pairs of angles. But they did give me that DE and CF are congruent. Now, those segments are too short to be sides of these larger triangles. But if I knew that EM was congruent to FM, these 2 segments, then I could add them together to get DM and CM. Now, luckily, they did tell us in the proof that the yellow triangles were congruent. So I can say that EM's congruent to FM because those are corresponding sides in those congruent triangles. So I can use CPCTC to say that those segments are congruent. Now I'm going to leave some space because chances are I'll have to use CPCTC for those yellow triangles again, and I can include that in my second statement. Next, what I'll have to do is I'll have to do the addition process. So I'm going to add DE and EM together, since that forms the whole side of these larger triangles. And then I'm going to add CF and FM together for the same reason. This would be the addition property. And I'd like to replace dE plus EM in the picture with this whole side dm. So I'm going to first say that dm equals dE plus EM. And I'd like to replace CF plus FM with CM. So I need to say that CM equals CF plus FM. And that's because of a whole equals the sum of its parts. And we always follow up a whole equals the sum of its parts by substitution. So in step 5, I'm going to replace dE plus EM here with dm, and I'm going to replace CF plus FM with CM. So those sides dm and cm have to be congruent. And that's helpful because it's a pair of sides in the larger triangles, which I want to show are congruent. Now, looking at other pieces of information that may help me with the yellow triangles that I already know are congruent, I go through each of the pairs of angles, and I'm trying to determine which pairs of angles are angles in the yellow triangle and these larger triangles, which I'll just highlight in red here. And I notice that this angle and this angle are angles in both of those triangles. I'll number them 1 and 2 to make this a little bit easier, and I can say they're congruent by CP/CTC. So I'll go ahead and write that up in my statement 2, since I already have the reason CP/CTC listed out. And that would be a pair of angles in the red triangles. Then I'll do the same thing with the corresponding sides of the yellow triangles that I know are congruent too. So I'll go through each pair of sides. I already know EM and FM are congruent. EA and FB wouldn't help me with the red triangles since those aren't sides in the red triangles, but AM and BM would. So I will also add that to my statement number 2. AM's congruent to BM by CP/CTC, and that's a pair of sides in the red triangles. So now I think I have enough information to prove the red triangles are congruent. That would be triangle ADM is congruent to triangle BCM, just as I wrote up here when we thought backwards in the beginning, and that's by side angle side, which allows me then to finish the proof by saying their corresponding sides AD and BC are congruent by CP/CTC. So hopefully you did pretty well in the review packet and you're gaining some confidence in these proofs that we've been working through over the last few days. Again, a reminder, tomorrow is going to be your Unit 5 test. Please make sure you're doing some extra studying tonight, that you go back and rewatch any videos from earlier in the unit on topics you're still having trouble with, and that you have plenty of proofs that you can practice both in the note packet that weren't included in the videos and in the class work packets that we didn't complete each proof from. And again, the class website is filled with answer keys for the classwork and for the class note packet for any proofs that you decide to do. So good luck in studying, and I will see you tomorrow.